All right, welcome back. Amazon Fraud Detector. Before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So, real-time protection against digital deception. Digital commerce has revolutionized business, but it's also opened up new avenues for sophisticated fraud schemes. Every online transaction, new account creation, and user login represents a potential attack vector. So traditional rule-based systems struggle to keep pace with evolving fraud patterns, while building custom machine learning solutions requires expertise most organizations don't possess. Amazon Fraud Detector addresses this by democratizing the advanced fraud detection, transforming what once required a team of data scientists into a managed service that adapts automatically to your business patterns and emerging threats. Okay. All right. So understanding the fraud landscape. All right. So modern fraudsters employ increasingly sophisticated techniques that evolve constantly. Online payment fraud exploits stolen credit cards and synthetic identities. New account fraud creates fake profiles to abuse promotional offers or establish footholds for larger schemes. Account takeover attempts use credential stuffing and social engineering to gain unauthorized access. Trial and promotional abuse exploits free offerings through multiple fake accounts. Each fraud type presents unique challenges. Payment fraud might involve legitimate looking transactions from compromised accounts, while new account fraud requires detecting subtle patterns in registration data. Account takeovers often manifest through unusual login patterns or device changes, and promotional abuse typically shows coordinated activity across multiple accounts. Amazon Fraud Detector recognizes these distinct patterns and provides specialized detection capabilities for each scenario, combining machine learning sophistication with business rule flexibility. So, what's the architecture of intelligent detection? Fraud detector operates on an event driven architecture where every significant user action becomes an analyzable event. This approach mirrors how businesses naturally think about fraud risks, specific moments when fraudulent activity might occur. So there's event types. These define the context you want to monitor, like user login attempts, new account registrations, or payment transactions. Each event type represents a distinct fraud risk scenario with its own characteristics and data requirements. Entities represent the actors involved in these events like user IDs, IP addresses, device fingerprints, or email addresses. These entities provide continuity across events, allowing the system to identify patterns that span multiple interactions. Then you have variables. These capture the specific data points relevant to fraud detection within each event type. Email domains, geolocation information, transaction amounts, device characteristics, and behavioral patterns all contribute to the detection model's understanding of normal versus suspicious activity. The system automatically performs feature engineering on these variables, creating derived insights like velocity metrics, like how many transactions in the past hour, or historical patterns, the typical behavior for this user, or contextual anomalies like the unusual location or time of day. Right. So these models represent the machine learning engines trained on your historical data to recognize fraud patterns specific to your business. Unlike generic solutions, these models learn from your actual fraud cases, understanding the unique characteristics of legitimate versus fraudulent activity in your environment. And then the rules. These provide the business logic layering on top of machine learning predictions, allowing you to implement specific policies and thresholds that reflect your risk tolerance and operational requirements. All right. So let's try and implement this. All right. Fraud. Amazon Fraud Detector. All right. Go to the console and get this and click the Get Started button. Let's see what we have here. All right. So it's pretty prominently displayed. There's an entry guide, shows explore the data models, build an event data set, build a machine learning model, build a detector, and get predictions. All right. So what are we gonna do first? So we'd use the setup wizard. Let's see. Let's try a detector. Oh, let's hope this works. Test count. Test new account. All right. Event type. Create a new event type. All right. Test new account. Okay. Let's tell it new account fraud. Let's try that. Uh, No spaces. Oops. No wonder. All A through Z, all lowercase, no spaces. Underscores are allowed. Okay. New account fraud. Let's create the entity. All right. And then let's see. Select variables from the list. We can create new variables. We can create label options, create the event type. I'm just going to cancel this. This is a lot, right? Um, uh, let's see. Let's see. Okay, let's try this. Online. Okay, let's try this. Let's try the wizard. Okay, let's try new account fraud with this. This is, yeah, this will be good. Create the event type. All right. New Amazon account. No spaces, underscores are allowed. Okay. New account. Okay. Select variables from training data set. IAM role, that's for permissions to access the data set, usually from the S3. Then you have the labels, you can create that. All right, so then you can define that event structure, have payment issues, user IDs, merchant IDs, all these different things, right? The variable configuration can let you specify the data points your application provides to each event. So the common variables can include the like stuff like the email addresses, IP addresses, device fingerprints, phone numbers, registration timestamps, and payment and transactions might include something like the transaction amount, anything more than zero, right? The merchant category, the payment method, and geographic locations, right? So each variable requires a different data type specification. So this will be a string, an integer, a float, or bool, right? So there's also optional validation rules, but the system uses these to perform automatic and feature engineering and creates derived metrics that enhance the fraud detection, right? So once you get that, you can upload your historical data through S3, and then the training data would be hopefully formatted as a CSV file with clear column headers matching your variable names and include a label column marking each historical event as fraud or legitimate, right? And then you'll be able to train your model, develop rules and business logic, and then deploy an API, right? So, what does that mean? So, Amazon Fraud Detector automatically handles the complex aspects of model development. The service performs feature engineering, which we talked about earlier. So, it'll select optimal algorithms, hyperparameter tuning, and cross validation to ensure robust performance. So, during the training, you can monitor progress through the console interface, which provides real time updates on model performance metrics. So, the system can calculate the precision, say the accuracy of the fraud predictions, and the recall, like the percent of actual fraud cases detected, and the overall accuracy scores. So upon training completion, the console will present a detailed performance analytics. It'll include confusion matrices, feature importance rankings, and curve analysis, right? And then the feature importance will have your model variable importance, which will help you understand which data points contribute most significantly to fraud detection. It's similar to what SageMaker has with Clarify, okay, with the explainability features. The rules and business logic will help you. Let's see. We have rules here. Ah, no, we don't. Okay, but the rules and business logic will help to add a layer on top of the machine learning. And the visual rule builder will construct logical statements like if your fraud score is higher than 8 on an 8 to 10 scale or 1 to 10 scale, and the country is in name your country, then the outcome would be block the transaction. Okay, so the rules can incorporate multiple conditions, different thresholds, different outcomes. You might create different rule sets for different risk levels, like high confidence predictions to trigger automatic blocking. Medium confidence cases might require a manual review or a phone call, and then a low risk transaction might proceed normally. All right. And the rule testing will let you validate your rule logic against historical data before deployment and ensure your business logic performs as expected. And then once you're deployed, okay, the API. Okay, so your model and rules being configured, Fraud Detector can create a prediction endpoint accessible via REST API. So then your application can call this endpoint in real time to evaluate transactions, account creations, or login attempts as they occur. And the API request structure is relatively straightforward. It'll go for, like your event ID, event type, event timestamp, and then the different entities like the user ID, all this different types of stuff. Transaction amount, which we just talked about. Okay. Okay. Um, it's okay. All right. So integration and operational excellence, right? So successful fraud detection requires seamless integration with existing business processes rather than creating isolated security silos. So Amazon Fraud Detector's API first design enables integration at multiple points in your customer journey. For e-commerce platforms, integrate fraud scoring at checkout to evaluate transactions before payment processing. And then account creation flows can incorporate real-time fraud assessment to prevent fake account establishment. Login processes can leverage it fraud scoring to implement risk-based authentication, requiring additional verification for suspicious access attempts. And then the feedback loop capability becomes crucial for long-term success. As your fraud prevention team investigates flagged cases, they can mark predictions as accurate or false positives through the console. And then this feedback continuously improves model accuracy, adapting to evolving fraud patterns and reducing false positive rates over time. And then the CloudWatch integration can provide operational monitoring. So you can track API usage patterns, response times, and prediction accuracy trends. And you can set up alerts for unusual fraud detection volumes or performance degradations to maintain system effectiveness. And pricing. Okay. So fraud detector is a pay per use pricing. It aligns with actual usage. So it's accessible for organizations of all sizes. The training data ingestion costs approximately 3/100ths of a penny per event during initial model training, while real-time fraud predictions cost around 5 cents per request. And for cost optimization, consider batching non-urgent predictions, implementing caching for repeated entity assessments, and tuning rule thresholds to balance fraud detection with operational costs. The ability to create multiple models for different fraud scenarios allows targeted deployment where protection benefits justify the prediction costs. So you can monitor fraud detection return on investment by comparing prevention savings against service costs. A single prevented fraudulent transaction often justifies hundreds of prediction requests, making the service economically attractive for most fraud prevention scenarios. And okay, so different capabilities, future considerations, right? So think about this, right? Amazon Fraud Detector integrates with SageMaker and it lets you have advanced workflows for organizations with special requirements. And then the custom models developed in SageMaker can incorporate fraud detectors predictions like features, creating ensemble approaches that can combine multiple detection techniques, right? So the services explainability features support compliance requirements in regulated industries like where fraud detection decisions require justification. And then variable importance rankings and prediction explanations can help satisfy audit requirements and support manual review processes. As fraud patterns evolve, fraud detectors' automatic retraining capabilities help maintain defection effectiveness without requiring manual model updates. The service continuously learns from labeled data, adapting to emerging fraud techniques while preserving effective detection of established patterns. Fraud Detector prevents or represents a fundamental shift in fraud prevention accessibility, and it transforms sophisticated machine learning into a practical business tool. And so you can handle complex technical aspects of fraud detection while maintaining flexibility for business specific requirements. So the service can enable organizations to implement enterprise grade fraud protection while without having the traditional barriers of expertise, infrastructure, or time to market constraints. That's it for Amazon Fraud Detector. I think the next time, we'll probably figure out. Hmm, probably go for SageMaker. Yeah. Regardless, thank you for joining. I hope you have a good afternoon. But before you go, hit the like button, subscribe, and share this with anyone you know taking the AWS machine learning exam or associate exam. Excuse me. Anyways, have a good afternoon or a good day.